Learning Rule 1.4 is going to use this mass percent analysis information and use it in a quantitative way to determine something about a sample in a mixture. So what you need to know is that this mass percentage data is often used in compound identification. So by taking a sample of a substance and putting it into a mass spectrometer and finding the ratios of the mass or the formula mass of the substance, we can figure out what that substance is. We can also use the mass percentage data to figure out the purity of a chemical. And we do this most often by a process called gravimetric analysis. Gravimetric analysis, gravity, right, which is related to mass of a substance. So gravimetric analysis is something that you may see on the AP exam, and so we should really work this out. So gravimetric analysis, whenever you see this on the AP test, it's probably a purity check. Most of the time when you are asked about the purity of a sample, the way to determine the purity of a sample, you're going to answer that with perhaps a gravimetric or some sort of mass analysis information that needs to be determined. So here's an example of how that could work. We've got 10 grams, exactly 10.00 grams of sodium chloride, which we know is impure, but we don't know how impure it is. So we use something that we do know, which is a precipitation reaction, that chloride will precipitate with silver. And so if we add this impure sodium chloride to a solution of excess silver, then we should be able to get all of the chloride to come out as a precipitate of silver chloride solid. When we filter the resulting precipitate and allow it to dry completely, we can find the mass of silver chloride that was produced as a result of this reaction. Then we're going to use our dimensional analysis and our knowledge of the ratios in the reaction and the mass ratios of these chemicals in order to determine the original amount of sodium chloride that was added. We added 10 grams of impure substance, but we don't know the actual amount of sodium chloride that was in that 10 grams. So we start with what we've determined as a result of the experiment, that we've collected this gram amount of silver chloride. Then we can convert from grams of silver chloride to moles of silver chloride by using the molar mass of silver chloride. Next, we convert from silver chloride to sodium chloride by knowing that in the balanced chemical equation, it's a 1-to-1 ratio. For every 1 sodium chloride, we're going to get 1 silver chloride. So now we've converted our chemicals from silver chloride to sodium chloride, and we can calculate how many moles of sodium chloride that we added originally. But what we really want to know is grams. So we take the moles of sodium chloride and convert to grams of sodium chloride using the molar mass of sodium chloride. Now we know the total mass of sodium chloride that was originally added out of the 10 grams that we measured of the impure substance. So to find the percentage of sodium chloride in that impure mixture, we take the mass that we calculated divided by the original 10 grams, and we can find the percent of sodium chloride in the mixture. Now this, as I said, was often done as a purity check, but it can be done for any mixture of substances as long as you know that in your mixture, when you do this precipitation reaction, you're only going to react with one of the chemicals in that mixture. That's kind of a lot, but it does use a lot of information that you should already know or hopefully are starting to recall. So Let's get this into your study guide. We'll practice some problems and it will become more comfortable again.
Here's your first AP example. Pause the video, try the problem, and when you've got an answer, push play to see if you're correct. Because sodium and potassium have different masses, the percent of chloride in each of these salts will be different. And so if you had a mixture and you could find the percent of chloride in the mixture, you would know whether it was closer to the sodium chloride or potassium chloride sample. And so the mass of chloride is what you need in order to figure out which mixture has the higher percentage or proportion of potassium chloride. Here's your second AP example on this topic. Pause the video and try to answer the question. When you're ready, push play. This question is about gravimetric analysis, so you have to recall what I said the procedure was to obtain that precipitate as silver chloride and what types of things would disrupt the experimental procedure and result in errors in your analysis. So the first option here is failing to weigh the mass of the filter paper. That would definitely mess up your experiment. The second is about the temperature during the precipitation, which won't affect the amount that you collect. Number 3, wash the precipitate actually could cause a change in the experiment because it could, if without washing it, there could be extra ions clinging to the precipitate and changing the mass. And the last part of the experiment is to heat the precipitate to a constant mass, which is indicating that it's completely dry. If you don't have a constant mass and your mass is still falling, that definitely will change your analysis because you'll have a mass that's too high because water will still be stuck there. So choice E is the correct answer for this problem. Let's try one more. Pause the video, and when you're ready, push play. This question is also about gravimetric analysis, and so we remember that that has to do with forming a precipitate and then filtering that out. So of our choices here, the thing that we need to do for gravimetric analysis is to add something to make a precipitate. We don't see the actual word precipitate, but we do see insoluble salt, which is another way of saying a precipitate. And we want to make sure that this precipitates only with one of the metal ions so that we can figure out the proportion of the two to each other. If something precipitates with both of them, we'll end up with a mixture at the end, and that wouldn't be as helpful. So choice D is the answer, and you are all done with this video.